Welcome to the LLM Integration Playbook, where we explore how to connect large language models with existing systems. This slide sets the stage by showing core components like models, APIs, databases, and cloud platforms, plus a high-level flow from data ingestion to processing, orchestration, and action, giving a roadmap for turning data into reliable, integrated AI capabilities. Measuring success starts with documenting baseline legacy performance, identifying pain points, and establishing pre-LLM benchmarks. Next, set realistic KPIs that align with business goals and quantify expected gains. Finally, monitor weekly deltas, things like ticket resolution speed, code delivery velocity, user satisfaction, and cost per insight to prove ROI and secure ongoing executive sponsorship through consistent reporting. Legacy systems create a classic data bottleneck. Monoliths, mumps or flat files, SOAP endpoints, and siloed databases feed into outdated protocols and rigid schemas. The diagram highlights a clash between those systems and modern expectations like cloud-native, event-driven access, and AI-ready data. So the key challenge is unblocking that funnel to enable real-time, flexible integrations. Integration is often the primary blocker to AI rollout, with 91% of IT leaders citing it as the top issue. The main bottlenecks include architecture mismatches, GPU-hungry models on aging hardware, fragmented data quality and security gaps, all of which can create long backlogs and delay value unless addressed through targeted modernization and prioritization. Think of middleware as a real-time translator that bridges legacy sources and LLMs. It extracts and normalizes payloads into JSON and embeddings, enforces policy, feeds clean contextual prompts to models, returns generative outputs, and manages secure adapters and routing so source systems receive validated, compliant responses without exposing sensitive data or breaking downstream workflows. This playbook layer shows MCP bundles model-agnostic connection platforms that include adapters, orchestration engines, context builders, and compliance modules. Their job is to convert varied payloads into AI-ready prompts and enable Copilot-style experiences for systems like SAP, mainframes, and on-prem file shares, so AI features can be safely enabled across existing enterprise platforms. To reduce hallucinations in support bots, the flow starts with chunking internal documents and vectorizing them, then storing embeddings in a vector index like Pinecone or Face. At runtime, the system retrieves top K passages, concatenates them with the user prompt, and passes that authoritative context to the LLM so answers are grounded and the chance of incorrect responses is greatly reduced. Orchestration turns generative text into action by combining an LLM decision layer with function and plugin definitions that map text to concrete system calls. For example, the model may generate a request to create a ticket, trigger a CI pipeline, or reformat an order, and the orchestration layer executes those actions across CRM, CI, CD, and ERP systems while maintaining safety and traceability. Event-driven mainframe integration streams change events into a modern event grid like Kafka, where serverless listeners enrich and invoke LLM classification or summarization. The enriched outputs are then pushed to consumers such as Teams, Power BI, or ServiceNow, enabling near real-time insights and actions without costly polling or overloading legacy systems. This slide shows an AI-powered transformation pipeline for legacy code. Fine-tuned model parsing converts COBOL and MUMPS code into cloud-native Java or Python, emits code, auto-generates unit tests, and documents APIs. The results are tangible timeline reduction from 18 to 8 months, functional parity around 99.7%, and roughly 35% cost savings in modernization efforts. Embed retry mechanisms form an iterative code refinement loop where the LLM generates code, test suites run, failures are analyzed, and error traces are fed back as prompts for automated refinement. That closed-loop process can lift code accuracy from around 70% before iteration to roughly 90% after iterative cycles, minimizing manual rework and improving reliability. Governance and compliance are core to hybrid AI pipelines. Implement request and access control via RBAC. Apply prompt sanitization to redact PII. Run LLM inference behind guardrails. Validate outputs and log audits. Integrate data lineage tools like Microsoft Purview for traceability, and ensure adherence to standards such as HIPAA, GDPR, and SOC 2 across the pipeline. Ongoing monitoring and optimization require tracking performance metrics like log latency, token spend, accuracy drift, and user feedback. Operational actions include incremental retraining and vector store refreshes, threshold alerts with automatic rollback, human-in-the-loop, quality reviews and regular system updates, and tuning to keep models current, efficient, and aligned with business expectations. The roadmap outlines a phased approach. Phase 1 focuses on preparation pick, high-value use cases, and inventory data sources. Phase 2 sets up middleware, fine-tunes models, and runs a 4-week pilot. Phase 3 measures KPI deltas and hardens security. And Phase 4 scales successful patterns to additional domains while socializing wins enterprise-wide for sustainable adoption.